In this video, we are going to look at some special scenarios when solving a system of linear equations. Example 4, we have 2x plus y is equal to 4 and 6x plus 3y is equal to 6. You can either use the substitution method or the addition method here. Let's say we use the addition method. Now we do need to pick which variable we want to eliminate. I can see that it will take the same amount of steps to either eliminate the variable x or the variable y. So let's say we want to eliminate the variable y. Right now, the coefficient for the first y is 1, and the coefficient for the second y is 3. Between 1 and 3, the least common multiple of the two would be 3. So if I could make one 3 and the other one negative 3, we can add and eliminate the variable y. So the second equation, the coefficient is already 3. I can just make the first coefficient negative 3 by multiplying both sides of that equation by negative 3. That will do the trick. So the first equation becomes negative 6x minus 3y is equal to negative 12. And the second equation will keep the same. Now, when you add the two equations, negative 3y and 3y will cancel, as you can see. It gives you 0. Now, I did mention that this is a special scenario. Watch how the variable x also cancel out. So in the end, the left side of the equation will end up with 0, while the right side, negative 12 plus 6, will give you negative 6. We know 0 cannot be 6. This is a false statement. So therefore, we can claim that this one has no solution because it leads to a statement that doesn't make any sense. If you were to graph, this will be a scenario where two lines are parallel, which means they don't have any intersection point, and therefore no solution. Let's look at example 5. In this one, we're going to use the substitution method. The first equation, y, is already isolated for us. So all we have to do is substitute this expression into the second equation. So we have 8x minus 4, and instead of y, I am going to use the expression from the first equation is equal to 4. Now we solve for x. That's 8x minus 8x plus 4 is equal to 4. 8x minus 8x give you 0. So you end up with 4 is equal to 4. So this is the opposite of what you saw in example 4. In example 4, we ended up with a false statement. But in example 5, we end up with a true statement regardless of what x and y are, because eventually they will cancel. So because this statement is always true, you can say that there are infinitely many solutions. And if you were to graph, you will notice that these two lines overlapped, and therefore they have infinitely many intersection points, and therefore infinitely many solutions. Now we're going to look at one application problem. Example 6, Juan borrows $100,000 to pay for medical school. He borrows part of the money from the school, whereby he will pay 4.5% simple interest. He borrows the rest of the money through a government loan that would charge him 6% interest. In both cases, he is not required to pay off the principal or interest during his 4 years of medical school. However, at the end of 4 years, he will owe a total of $19,200 for the interest from both loans. How much did he borrow from each source? First, let's go over the interest formula. I is equal to PRT, where I is the interest earned, P is the principal, which translates to the amount invested. R is the interest rate. And T is time in years. So when you borrow a loan, the lender typically will enforce an interest rate so that over time they can make some money off of the loan that you borrow. And that amount that they make is called the interest earned. In this case, it'll be the interest that Juan has to pay from the loans. So I'm going to add interest earned or owed. Now, let's look at the problem again. Juan borrows 100,000 to pay for medical school. Part of his money will go to one account that has 4.5% interest, and then the rest of the money will go to another account that has 6% interest. So let's call X to be the amount in the 4.5% account, and Y will be the amount in the 6% account. We know for a fact that these two amounts will add up to 100,000. Now let's talk about the interest that he'll have to pay. So with the X amount invested in the 4.5% account, applying this formula, X here would be the principal amount. The interest rate is 4.5%, and T's in years, which in the problem it mentioned 4 years is when we has to pay. So let's substitute all those numbers in for the first account. So the interest for the first account, principal is X, so that's P times R, 0.045. We do need to convert the percent to a decimal number, and T is 4 years. And the second account, that would be Y amount, so Y dollars times 0.06 times T. Again, I am applying the interest formula, this part of the formula anyway, the P, R, and T. And that will give me the interest earned or interest owed in the first account and interest owed in the second account. Now we know that these two interests will add up to 19,200. That's what it says here. He will owe a total of 19,200 for the interest from both loans. So this equals 19,200. So as you can see, we just created a system of linear equations. Let's rewrite the system. Here's the first equation. We're going to go ahead and multiply these two numbers together. So 0.045 times 4 should give us 0.18 times x. And then these two multiplied together will give us 0.24 times y, and that equals 19,200. Let's use the substitution method. So first we need to get a variable by itself. Doesn't matter if you get x or y by itself here. Let's say we get x by itself. This is what we end up with. Now we are going to substitute this expression into this x of the second equation. So the second equation will become 0.18 times 100,000 minus y plus 0.24 times y, and that equals 19,200. Let's simplify this equation by using distribution. So 0.18 times 100,000, that's going to be 18,000, minus 0.18y, bring down, plus 0.24y, equal 19,200. These two are like terms, so we can combine them as 0.06y, bring down the 18,000. This is a positive 0.06y, so let's put a plus sign there. Now we are going to solve for y, or isolate the variable term, by subtracting 18,000 from both sides. And that will give us 1,200 on the right side. We will then divide both sides by 0.06, and that will give us y equal 20,000. Now, what did we just find? We found the amount in the 6% account or the 6% loan. Now, how do we find the amount in the 4.5% loan? We know the total of the two is 100,000. So based on this equation here, actually, in fact, let's use this equation where we have x is equal to 100,000 minus y. So x is equal to 100,000 minus 20,000, and that will give us $80,000. Let's write a conclusion. He borrowed 80,000 from the school, which is the 4.5% account, and 20,000 through the government loan, which is the 6% loan.